In this video we have another trigonometric interval to evaluate. If you want to give this a try, go ahead and pause the video and I'll be right back. So in the integral we have 12 sine squared of 4x cosine of 4x dx. We know the derivative of sine is cosine, so that gives us a hint to use the standard U-substitution. So I'm going to let U equal to sine of 4x. Then du will equal to the derivative of sine is cosine. So we have cosine of 4x, and then using the chain rule, derivative of 4x is 4, that goes out in front here, and we have a dx. Notice over here we have cosine of 4x on the right, so we can divide both sides by 4 here. Instead of solving for dx, I'll solve for cosine 4x dx. So dividing here by 4, we get cosine 4x dx is equal to du over 4. And then we just transform this integral into one involving u. So it's the integral then of 12, and then it's sine squared of 4x, but sine of 4x is the u. So this will be, just write u squared here in place of sine squared of 4x. And this cosine 4x dx is replaced by du over 4. And we divide the 12 by 4. And we get 3 u squared du. Now we can just integrate with respect to u. Add 1 to the 2, we get 3. So this will be u to the third. And then this 3 gets divided by 3, so this is simply a 1. Or I can just leave it u to the third plus the constant of integration. And we're pretty much finished there, other than going back to the original variable. The u is sine of 4x, so we finish up by saying this is equal to the sine cube of 4x plus the constant of integration. So this is your final answer. Sine cube of 4x plus the constant. Thanks for watching. We'll see you next time.